Welcome to class. Today we're going to go over week 3. Week 3 mostly covers the while loop and multi-way if, random numbers, and logical operators. So it's some important stuff that we have to get through. When you listen to the lecture, I'll tell you when to pause the video, and then you should try to work out some of these programs on your own. Alright, so let's start with the multi-way if. So the multi-way if is a more robust way of doing if and else. So we previously know about the if-else, and the if-else has only 2 possibilities. But what if you have more possibilities? So let's look at this example. Grades is a list of grades. Now a for loop can grab each individual grade inside the list grades, and then we could do something with it in each iteration. So for each grade in grades, it'll take one grade at a time, starting with the 75. If the grade is greater than or equal to 90, then we're going to simply print you earned an A. And that's it. If this if is true, we go right here where I'll put something down that doesn't really matter called pass, that's like a placeholder. We would go right to here and go to the next grade. However, if grade was not greater than or equal to 90, then it would check line 6. Is the grade greater than or equal to 80? If it is, well, we print a B, and then we go on to the next grade. Otherwise, we keep on going down checking to see if one of these elifs is true. They may not be. The if and all the elifs may be false. If that's the case, we go to the else. So if we go to the else, then it means that none of these were true, and something was wrong. Is something really wrong? No, but we just say something is wrong. So try to think, what would cause us to get to this oops, something is wrong? Like what number would they have to type, would have to be in the list for that to happen? So hopefully you figured out that if all these would be false if the grade was less than a 60. So let's run it and see what happens. All right, so I already ran it previously, and this is the output. But here, now it just generated again. So notice when it gets to the 6th grade, 1, 2, 3, 4, 5, 6, the 55, it triggers the else. And it never gets to the 7th or 8th grade because we broke out. The break breaks out of the for loop. It breaks out of every loop you're currently in. So that's the if elif else construct. Notice the three parts: if, elif, and else. Alright, so for loops can grab individual characters from strings. So take a look at this little example here. So we start with word, and word is the string Python. And the purpose of this code is to take each letter from Python one at a time and to do something with it. So let's see. So letter takes P, then Y, then T, then H, and it concatenates this double star. And then it prints the new letter. So it takes each letter and does something to each individual letter. Alright, so looking at the code here and the output, notice it just took each letter and modified it a little bit. Alright, so here's a little exercise you should try. You should pause the video for a couple minutes. Ask the user to enter three numbers. Calculate the average. X. If X is greater than 90, display A. If it's between 60 and 90, display C. Otherwise, display F. Use an elif. Now, when you ask for the three numbers from the user, you're using input, of course. You are probably tempted to simply just use three input commands, but maybe try to use a loop, maybe a for loop or a while loop if you're more ambitious, just to get a little practice getting data from a loop. Because what if I had 20 numbers to input? Then you would want to use a loop for that, and you wouldn't want to do it with 20 statements. Alright, so unpause, and here's the answer. So notice what we're doing. We loop 3 times with a for loop, and we require the user to enter a number X, and if the number X is bigger than 90, we print A. Else if it's greater than or equal to 60, but so if we get to this statement here, X is not greater than 90, so it's automatically less than or equal to 90. So you have to keep that in mind. Alright, and if it's not greater than or equal to 60, it's below 60, in which case we would print an F. Alright, so running the code, let's see. 35, that's an F. 68, that's a C. 99, A. Alright, so this is going to look a little strange, but you can do math with logical operators. So just to show you, true or true, and false, and not true. So you could give Python some complicated expression of true, false, and, or, nots, and it can basically do the math. It's basically binary math, logical math, just using zeros and ones. This is how computers work. Digital computers, that is. Now, after you calculate an expression with logical values of Boolean values, then you can store the result in another variable which will be Boolean. So let's take a look. So look at the lines 1 through 3. A is true, B is false. C equals A or B. So the way to read this, and you don't need the parentheses by the way, I just put them there for clarity. So the way you read that is, you first do the right hand side. True or false is true. Remember, you're true if at least one of the or, at least one of the variables in or is true. So you first evaluate the right hand side, and whatever you get, in this case true. Then the last thing that's done is it's assigned to the value C. So the left side is done last. So don't read it C equals A or B. Read it A or B. The value of that is stored in the variable C. So C has the value true. D equals A and B. So A and B has A and B evaluates to false because one of them is false. And D gets the value stored for the evaluation of A and B. D is false. See, something like this looks strange, but it's the same thing. Is 5 greater than 7? False. Store the answer in E. All right, I'm going to skip this part right here. I think it's safe to skip this. I just generated a truth table. If you want to try to understand it, you can. But I think we're better off spending more time on other important stuff. Okay, the while loop. So when you use a for loop, you need to know exactly how many times the for loop is going to run. So for example, like you could say, for I in range 10, print hello. So this will do it exactly 10 times, right? But let's say we didn't know how many times the loop is supposed to run. Like suppose it's complicated to figure it out. Suppose you want to keep on looping until something is done, until something has occurred, until a user has entered quit. In that case, you need a more powerful loop called a while loop. So the while loop checks for the truth of a statement, and as long as it's true, it will keep on running the while loop. And when it's false, it'll terminate, but it won't terminate the instant it's false. It only will terminate after it checks that it's false. So we'll see. Let's give it a try. All right, so look at this code right here. N is 0. As long as n is less than 10, print n, add 1 to n. Let's run it. N is 0, print 0. Now n is 1. Is 1 less than 10? Yes. Print 1. Now n is 2. Is 2 less than 10? Yes. Print 2. Keep doing this until we get to 9. 9 is less than 10. Print 9. 9 plus 1 is 10. N is 10. Is 10 less than 10? No. So it does not enter the while loop. While loop is over. And notice we finish with 9. So 9 would be the last number that gets printed. All right. Now this while loop is going to look a little strange. Why don't you pause the video for a minute and try to figure out what you think the output of this code is. Like, what's happening here? All right, well, no there is true. We're not there yet. I didn't want to use not there because I didn't want to confuse you with the not operator. So I use the word no. All right, so no there is a Boolean value and it's currently set to true. C is 0. While no there, what that really means is while no there is true. It is true. It started out as true. So we are going to enter the while loop. Okay, print still going. C equals C plus 1. All right, now C is 1. Is C equal to 20? Well, not now, but when it is, we're going to set no there equal to false. So this will keep running until C is equal to 20. It'll run about 20 times. And when it reaches 20, when C reaches 20, then no there will be set to false. And then when we go back to line 3 to see, should we enter the while loop again? No there is going to be false, so it will not enter it. All right, so you could have also written it like this. I would suspect that beginner programmers would probably rather write it like this. While no there is equal to true, double equal to true. But I'm just letting you know that you don't need that, and it's fine like this, and it means exactly the same thing. All right, so how many times did it run? Well, it printed when C was 0, and when C got to 19, it printed. Then it made C 20, and when C got to 20, it's going to stop printing. So it looks like it's going to go from 0 to 19. All right. So take a look at this code and see if you can predict the output. So pause the video for a minute and try to predict what the output is. All right, let's run it. Okay, notice it subtracts 1 from n each time, but it only enters the loop when n is greater than 3. So once it's equal to 3, we no longer enter the loop. All right, so the answer is 10, counting down to 4. All right, so let's try a little exercise. Using a while loop, ask the user to enter a sequence of numbers. When they enter -1, stop. All right, so this is a very important exercise. Many students have a lot of trouble using while loops to ask for information. The order really matters. And it really matters what's inside the while loop and what's outside of the while loop. What's before the while loop and what's in the while loop. So many students have made mistakes on these kind of questions where they put the wrong things in and out of the loop. You have to also think about where you are in the loop. Like, are you just starting in the loop, or are you continuing in the loop and you were previously there? You have to really keep all that in mind. Alright, so unpause the video and let's take a look at the code. Alright, so let's run it. Alright, so we're going to just enter a bunch of numbers. And notice when I enter -1, it stops. Alright, this code is really, really simple. It's only 3 lines. And I would expect that if you tried to write this yourself, it was probably more than 3 lines of code. But you only need 3 lines of code. Okay, how does it work? First we get our first number. Then we check, is this number not equal to -1? If it is -1, we never enter the loop. Right, and we could test it out. It's a good idea to test out these cases. If it's not -1, we enter the loop and we get another number. And then we keep doing that until the number we enter is -1, and then we won't ask for any more numbers. Alright, next exercise is also very important. Make sure you could do this kind of thing for the test and stuff. Using a while loop, ask the user to enter a sequence of numbers and add up all the numbers. When they enter -1, stop. Don't include the -1 in the sum, so be careful there. And you will need to keep a running total. Alright, so give it a try. You want to modify this code here. You definitely want to use that code. Alright, I'll give you a minute to try. If you need more time, you could of course pause the video. Okay. Alright, so here is the answer. Let's run it. Alright, I added up all those numbers and it looks like I got 15. It's a good idea to test it out. Like if I type in -1, I get 0. 1, 2, 3. I think I entered it a little bit too fast, so try again. 1, 2, 3, -1. See how the -1 does not interfere with the sum. So how did we do this? Well, we got our number from before, like we did, but now we're just going to keep a running sum, s. As long as n is not -1, add n, the number from the user, to s. Then get another number. But don't add it. Okay, so you get another number. Now this is what's a little tricky. This number n doesn't get, and maybe this is why people have so much trouble with putting things in the wrong order and putting things inside or outside of the while loop in error. So we think of a loop running in circles. We start out with our first number. It's not -1. We add it to s. That's easy. Then we get our next number n. Let's say we plug in the number 2. Now next we go here and we see 2 is not equal to -1, so we're good. We enter the loop. We add to our running sum, the number 2. And then we get our next number. So what's confusing is normally line 5 comes before line 6. But then when you loop around, line 6 will come before the next iteration of line 5. So keep that in mind. I strongly encourage you to really understand this code. It's so simple. It's only a few lines. But I guarantee that many people will have a lot of trouble doing this themselves. Alright, so let me modify this a little bit. See if you can figure out what it does while I just make it a little simpler. It's a little bit complicated. What we want to do is ask the user to enter numbers and find the biggest number so far. You know what, maybe I will leave it the way it is. It is a little complicated for my taste, and I probably won't ask you this complexity on exams, but still, maybe it is useful to show you a little bit what like a real program looks like. So let's see how this runs. Enter a number, positive number to quit. 6, 10, 4, 7, and then Q. Alright, it told me that the biggest number I entered was a 10, which is correct. Alright, how does it work? So first of all, if you get one thing out of this, it's the infinite loop. See how it says while true? That's always true. True is always true. You cannot make true false. And you cannot make false true. True is true. So that will never change. So the only way out is break, is to use a break command. Right here, line 12. Now, you know when like your computer like hangs and it's just doing something forever and it never stops and you have to reboot it? That's basically an infinite loop. So you don't want infinite loops. You want to make sure that you can break out of them. Okay. So inside an infinite loop, let's get some text from the user. We want a number, but what if the user doesn't enter a number? Well, let's see. Let's say enter not a number. It says I didn't enter a valid response. Let's say enter a character, not a response. Let's enter -1. I didn't enter a valid response. See, this is a more sophisticated program because it's checking to make sure the user enters the right response. All right, so first thing, we get text from the user in line 4, we check, is it numeric? So that's a method that we're using, a built-in method of Python. And as long as it's numeric, we know it's a number. So in lines 5, 6, and 9, up to line 10, in this block of code, see how it's indented one level at least? So that means that it's numeric. We guaranteed that txt is holding a number, integer or decimal, negative or positive, or 0. All right, so let x be the conversion into a float. That will work because it's numeric. All right, big so far is none. What is none? Well, none is no answer, no value, empty, uninitialized. It's a special keyword, a special value to be the null value, the value that has no value, like the empty value. All right, so if big so far, and big so far is going to hold the biggest number that we've seen so far. If big so far is not none, then it means it's a number. So we can check it. Is the number x that we just plugged in, is it bigger than big so far? If it is, then we found a bigger number than big so far. Let's call it big so far equal to x. So what this means in line 7 and 8 is x is the value that came from the user. And if it's bigger than the biggest number we're holding in memory right now, then what we know that we could replace big so far with the number that just came in. Okay, now this else does not go with this if. So lines 7 and 9 are not tied together. Lines 6 and 9 go together. So if big so far is not none, well, let's check if the x is bigger. Otherwise, what does this mean? What does it mean when we get to line 9? So in class, I would ask this question. If we get to line 9, what does that mean? The answer is, this is the first number the user has typed in that's valid. Big so far is currently none, and we've never initialized it yet. Okay, now line 11 and 4 are tied together. So if the text is not numeric, well, let's check if they entered Q. Okay. If they entered Q, then we break and we're done. And finally, else, we get to this if we did not enter a valid response. So we get to the else if it's not numeric and it's not equal to Q. So if both of those are false, then it means we get to the else. Now, looking at some of the output, if we enter a string, we get you didn't enter a valid response, so we get to here. If we enter a character, we got the invalid response. And if we enter a -1, we didn't get a valid response. So that's a little strange, because I would think that -1 was a numeric number. Let's check that. So how do we check that? So let me show you how to experiment a little bit. So let's open up a little code. So let's let u equal -1, -5. And let's say u is numeric. If you hit the tab key, it'll complete. So the tab key will complete your statement for you. Let's see what happens. False. Strange. -5 is not considered numeric. But 5, let's see, is 5 numeric? Yes. How about 5.0? How about negative? 5.0 is not considered, is not numeric. How about -5.0? All right, so it looks like this does not like decimals. Is numeric does not like decimals. So you'd have to read about it. All right, so you'd have to read about it. Okay, so let's run this again. And this time, let's type in 5.8 and see what happens. It doesn't like it. So the answer to our question, is numeric, only seems to accept positive integers. Does it accept 0? Let's see. Yes, so it looks like it accepts it accepts non-negative integers. There are other functions out there that you could look for. See, for example, is maybe float. Let's see if that's one. All right, so we'll come back to this later, but don't worry about it. All right, let me get rid of this. Okay. All right, so this code finds the biggest number you entered so far. All right, let me see how much time we have left. Not too much longer. All right, so let me quickly go over random numbers, and then I'll pause the video. All right, random numbers are super important in real life because they can be used to simulate reality. They're used in probability and statistics. They're used in simulations. Like if you wanted to simulate a shipyard, you would use random numbers to drive various random events. If you wanted to have the computer simulate games of poker or craps, you would use random numbers. Okay, we need the random library in order to do this. So let's start with importing random. Then we could use a neat function called randint that will generate random uniform discrete distribution numbers between 3 and 6, including 3 and 6. So let's take a look at this code. Notice how the numbers change every time I run it. See? It's because they're random. It's not easy to make random numbers. If you tried to do it yourself, you would find it a little harder than you would expect. Because these are truly random. If you just try to write them down on your own, you would see that they wouldn't really be random. And even these are not truly random, but they're close. All right, now let's say we want random seeds. These are random decimals between 0 and 1. This is the uniform continuous distribution between 0 and 1 for those of you that have already taken probability and statistics. And these are used to seed other random variables. You could use them to generate other events. So each of these digits is equally likely to occur, and each of these numbers, if you did like 1,000 of these numbers, you would find that they would fill in the unit interval pretty nicely. They wouldn't fill in every number, of course, because there are uncountable numbers in the unit interval, but it would start to sort of shade in the interval. All right, so the method you use is random.random, and that just gives you a random decimal. Notice we get different numbers each time. Okay. Other useful things are random choice. So if you have a list, random choice will grab a random number from a list, and random.shuffle will shuffle your list. So notice each time I run it, you get different numbers. Okay. All right, so see me in the next video to work on these classwork problems. So I'd like you to work them out on your own. And I will go over all 3 of them, and I'll try to explain how I solve them and try to help you to see, try to help you understand the thought process to writing these.